If you saw me this morning, you have a small idea about what I'm going to talk about. But in this session, I really want to go into a lot more detail about the technology that we've been building. So just to talk a little bit about, I'll cover a little bit of the introduction as to why we're doing this. But then I'll go through and start looking at the technical challenges and why we've built the technology the way it has to solve this problem. So let's start with an example. So here is a data scientist, Callie, and she's taken two sources of data and decided to combine them together. So they're both sort of public data. One of them is the employee directory, and she's found an open source site that actually has the registration of births. So she said, well, that's quite good. I'll take these two data sets, I'll combine them together and build a birthday card service. Now, depending on what you think about that, on one hand, that's a little bit dodgy from a privacy point of view, even though these are seemingly public data sets. And the other thing that happened is that when she tried it, it turns out that it didn't work. And the reason it didn't work is that she misunderstood what the date was in the records that she picked off the open data site. So she thought it was the date of birth, and actually it was the date of registration, which of course is a few days out. So not only is her service a little bit dodgy from an ethics point of view, but it also doesn't work. And the fundamental problem is that she's guessing what the data means. What she really needs is, when she's picking up a new data set, to have a detailed set of information about where that data set came from, what's how it should be used according to the policies of the company, because the way we use data really impacts our brand and the way that people consider your company's respect for their data. So this is an extremely important aspect of how a company is perceived by its customers and its employees in terms of how it uses data. So this set of properties is what we call metadata. Metadata sort of tends to strike fear in people's hearts because it seems to be a very difficult technical thing, but it's actually descriptions of data. That's the best way to think of it. And it's a very broad topic. It's not just, let's just capture the schema of all our data sets, let's just keep a spreadsheet of a list. It's a very detailed description of where this data's come from, what it means, how it should be processed according to company policy and legal regulations and all that sort of thing. So I'm going to go through a little bit more about what we mean by that data and also what it takes to bring it together into this beautiful form that actually means that people who pick up data sets actually can make better use of them. Now, when you start talking to people about what they need to do with data and how do they support their data environment, you get very different answers from people. So Callie, she's the data scientist. She wants to find data, understand it, and build analytic models. That's her role. Jules Keeper, he's the chief data officer in this scenario. He wants to build a data strategy and a governance program. This is moving forward without my help. Here we have Faith Broker. She is the HR and privacy officer. She's very interested in understanding where personal data is located and ensuring it's properly protected. Gary works in IT. He is interested in ensuring his IT infrastructure that supports the company's assets is, I don't know why this is moving forward automatically. I don't know whether I can step it back. Let's see. There we are. No, let's stay with there. So he's very interested in maintaining a proper IT infrastructure, making sure that the APIs and services that are deployed are right for the business, and being able to locate and resolve issues fast. So they seem to have, each person seems to have a focus. But when you actually look at what they're trying to do and you think about what data they would need, it all starts to come together into a fairly coherent data model. And this is the data model that we have added to Atlas. And Atlas has I'm really not touching this. I'm going to disconnect the the chart advancer because it's decided that I'm only going to advance I only need to advance every second, and that we're run out of charts if I do that. Right. So this is the sort of outline of the data model that we put into Apache Atlas. Apache Atlas has a metadata strategy that is a type system that allows you to incrementally add types to it. So even when it's running. And so we have defined about 350 types that fill out this data model and cover areas from, let's just understand the data assets, let's describe its meaning. So this is with the glossary piece up above. The governance piece is about defining data strategies, understanding, documenting regulations and their requirements associated with it. It includes the how those requirements are then translated into actions, so rules and things that actually need to execute inside the tools and the runtimes. So that's all in the governance area. Lineage is capturing the processes, details of the processes that actually created the data set, so that we can understand where particular data came from and how much it can be relied on. The yellow area is base type. So this is really describing the infrastructure that's supporting the data sets. So for example, if the data set had personal data in it, is that infrastructure supporting encryption? That would be an example of the types of things that we would keep in the infrastructure area. Metadata discovery is a process where data is analyzed using different types of analytic model, and its characteristics are captured and then attached to the detail of the data set itself. So, and what else have we got? Oh, models and reference data. So if you imagine data has code values in it, that's reference data. And we need to be able to understand what those code values mean in order to be able to understand the data. So models give you best practice structures for data. And we use that when during the engineering phases of new data sets and services in order to make sure that data is in a consistent and compliant form. And finally, the pink area, the collaboration area. So this is about the use and the feedback around particular data sets. So if I'm an owner of a particular system, my data's gone into the data lake, the data scientists are working with it and are finding problems with the data or asking questions. That collaboration area actually brings that information back to me. So this is quite a comprehensive set of metadata that's really needed by an organization if they want to make good use of data. Now, how do you bring all that together? It's a process we call curation. And it's something that we just can't expect people to do out of the goodness of their heart. I mean, typing in descriptions of data sets is very boring. It's very time consuming. And if we rely on people doing that, as I say, as a spare time job without any incentive for getting it right, then it's really not going to have any value, and it certainly won't be trusted by the data scientists to make use of it. So we need to think about how we bring this metadata, or the process of gathering metadata. We need to make sure it's automated, but also if we rely on people to provide that information, it's a part of their job, and by providing that information, they get value back. So it's always this exchange, making sure people who are involved in the ecosystem get value as they put value in. The other aspect of it is we need to make sure that people who own data and who are responsible for data are able to affect how it's used. So here we have Faith, who is in HR. She needs to be able to set policies for how the HR data, the employee data, for example, is managed, and for the underlying infrastructure to pick that up and operate with it. So when you take those two pieces together, it means that the metadata capture has to come from many different products, many different tools, and be embedded in the runtime. So this isn't a single repository that's sitting in the background allowing people to look stuff up. This is something that is distributed and embedded and cached and refreshed within the underlying infrastructure across the organization. And that's why this is an incredibly big task, because it's not about one piece of technology that we put in place and the answer's done. This is about enabling an ecosystem across not just the Hadoop environment, not just the data science environment, but actually to start encompassing all of the data, particularly the data that is pulled out of its original system. So we call that application-independent data. Because as we pull that data out, it's losing its protection. It's like you've got a tortoise and you're taking its shell off, because the original application has all the logic that protects that data, determines who can see it, probably allows you to only see one record at a time, and basically has all the rules about how that data is used. When you take it out, that protection is gone, and it's the role of the metadata and governance function around how we move that data, how we use it, that actually replaces the protection that the original application had. So we need to get this technology into a lot of different places, and there's no proprietary product that would be trusted to do this, and this is why open source, open standards is absolutely critical in making this work. It has to be an ecosystem that vendors can connect into and make money. It has to be something that supports what businesses are really trying to do with data, and enables them to be more effective with data. So, I was going to give you a little bit of a feel for some of the things we can do with metadata as we build up its maturity. So in this picture here, you can see we've got some data, and you can look at it and sort of guess what some of this means. This looks a bit like an address here, New York, and New York's coming up here again. That might be a name, sort of job title. So you can start to pick out and guess what some of this data is. If you know its schema, say it's come from a database, this starts to show where the field boundaries are. We might get a name for things. So again, it's a lot. You can really start to understand. Oh, that's interesting. That's the salary. We know what that is. But some names on columns are really very obscure. And they're certainly difficult for businesses to understand. And when we've got something like a job code, well, what does that actually mean? Is that their salary? Is that their level? Is that the type of role they do? Is that their skills or whatever? So we need we need a little bit more information. So this is where we start using, glossaries. I talked about this glossary area in the metadata repository. So here we've added in some definitions, and this would include a long description of what does annual salary mean, and what does job title mean, etc., etc. So we start to get a bit of understanding. But of course, terms on their own don't tell you everything. So we can also add what we call an ontology on top of that, which starts to show how things relate. So what this is saying, it's like a very loose data model in many respects. So we're saying that an employee, and a manager is a type of employee, has these types of attributes. It's not imposing a structure, it's just basically saying these are the sorts of things you would expect. So when you start sort of relating things to it, you can start to say, yeah, okay, so this is the type of information I would expect around an employee. And we can say, well, here's annual salary, and it's a compensation plan. Or we might see an hourly pay rate as an example. So we start to understand a little bit about the relationship between values that we would find in these data sets. And then we can start to say, okay, this is compensation data. As a business, we're going to treat this as sensitive data. And that means any data set that maps into either annual salary or hourly pay should be treated by the underlying infrastructure as sensitive. We can take that, and if that knowledge is then embedded into the security environment, as the right data, as the data passes through, and we look at its associated terms, we can then understand how it should be treated in terms of sensitivity. So when we look at metadata, we really need it for all uses of data. which is analytics, that's true, but business applications that work on data that's been derived elsewhere. Maybe it's come from externally from the organization or internally, and for reporting. So it's basically when we pull that data out of the original application. And it covers much more than its structure, format, but it covers where it's come from and what it means and how it should be used. So metadata is actually a critical part of making data useful. Now, when we look at products today, we see that a lot of products recognize the importance of metadata, and they even offer a metadata repository. That repository generally has a philosophy that it's the only metadata repository, and that everything needs to be loaded into that repository for the tool to work. So when you bring in a new tool, it's empty, and you then have to go through the process of populating it with the knowledge of your data in order to get it to go. So there's a sort of a period of startup for the tool to become really valuable. And then you buy a second tool and you start the process again, and the third and the fourth. And the effect is you start to think, well, we won't buy any new products. What we'll do is we'll extend what we've got, or we'll try and create the integration. So there's a lot of companies that are trying to create this integration between metadata repositories, so they're not continuously having to update the same, update each tool with the same information. So this is what you end up with. You end up with an environment where each tool knows a slightly different subset of the data within the organization. And if the tool is only being used for a single project that has a specific scope, that's not a problem. But the moment you want to pull together an enterprise catalog that has all these uses, that's able to control runtimes as well as allow business users to capture and manage things, you then struggle because you're either down to using tools from one vendor, or you're constantly moving metadata around between the different repositories. And it can be fairly fast moving, and in an organization that uses data a lot, there's new data sets coming online all the time, and so this maintenance can be very expensive. So simply put, what we're trying to do is to allow metadata repositories from different vendors to connect and exchange metadata using open standards. We're also providing most of the logic to actually do that exchange. So we're not relying on every vendor to implement that protocol between the two. They can download and use the open source technology that we're building into Apache Atlas and incorporate that in their product. I mean, they can implement it if they want, but it's there and available. So by providing that logic, we're hoping that tools should integrate much more readily, rather than us having to do an integration test between different vendors' interpretation of the protocol. As the ecosystem builds up, you should end up with, with different repositories able to share, whether they're on the cloud or within your own data centers. And what you see is each repository typically accompanies a tool and a community of users. So the assumption is that when you create some metadata, it's stored in your local repository and then shared. All updates come through that local repository, whichever repository the request comes from, it's always routed to that originating repository. So you end up with clusters of metadata that's relating to the community that sits around that metadata repository, plus the ability to share. The peer-to-peer nature of this is critical if we're going to build trust across lots of different vendors. We don't want, one repository to be in charge and basically dictating the metadata that others see. So the aim is to try and create fairness across the ecosystem. So why did we use Apache Atlas? So Apache Atlas is not very old. It was very focused on Hadoop, but it has a number of features in it that make it brilliant as a base of this platform. I mentioned one of them earlier on, which is this ability to add types. So it starts almost empty. It doesn't really know very much about types, and it allows us to build up this set of standard types. So we haven't got any history to deal with, really. The other thing is that it's established very early on that metadata capture should be automated. And so there's an architecture in it that talks about, that provides this idea of hooks and bridges that is, that basically they're embedded into different Hadoop components and that metadata is captured. And to me, this is a very, very important part of what we need in an open metadata ecosystem. So that's why we picked Apache Atlas as the base. The fact it's open source gives us the right type of software governance system that we need in order to build trust between vendors as well. So what we're adding to that base is a number of fairly large components. Now, the bottom here is called the repository services, and this is the component that allows any server that embeds them to talk to others, and we call this the metadata highway. So with that component, all of the protocol management, both in terms of being able to issue federated queries and to exchange metadata, to replicate metadata between repositories, is added to that server. The next thing are these access services. So I'll go into a bit more detail about what access services, but think of it as a specialized API and event exchange model for different types of tools. So there's 18 different access services that cover different parts of the data tools space, BI, data science, API development, all those things where metadata needs to be captured and managed. And then the third piece, and this is the bit that we still have to do, which is actually around the automation and management of analyzing data sources, providing stewardship to handle exceptions that are discovered within data, and the automatic capture. So our focus initially has been on these two pieces, which is the open metadata, and this I call the open governance piece, and that's work to do. There are many thousands of metadata standards, and they're good. They're written by people that really knew what they were doing, but they're very narrow. So this is DCAT, which is a standard for data catalog, and you would think, okay, this is a really good starting point, and it is. There's nothing wrong with it. But when you look at what it contains compared to the model I showed you, it's a small part of the piece. So we've taken a lot of inspiration from these standards, and we're also working with the Open Group to create a tagging mechanism that allows us to show the correspondence between something like the DCAT standard and the standards that are implemented in the open metadata model, so that we can very easily build bridges between a compliant DCAT catalog and an open metadata catalog, because open metadata is effectively a superset of many different standards connected together. And what's been good is that many of them are actually fairly compatible with one another. We've not hit anything that's been a major showstopper in the fact that two metadata standards are completely incompatible, and they even make use of each other. So here you've got the SCOS standard being used inside the DCAT standard. So there's been a lot of work to make my life an awful lot easier in terms of building this model. Inside Atlas, we have a very nice model, and in fact, we've simplified it even more than the base Atlas definition. So we have the concept of an entity, that's an object, a classification of that entity, which basically tells you a little bit more about its type or group. So you might, when we classify something as sensitive, we're using a classification object. And then we have a relationship that can connect two entities together. And each of these, and so the structs are actually in the original Atlas model, but we've removed that from the open model because we haven't actually found a real need for it. So we've kept it simply to relationships, entities, and classifications. Each can have properties in. So, this is a data set, say a database column. This is a glossary term. It's classified as sensitive. And then this relationship here may have properties in it that says this is how confident we are that this is the right definition. This is when this was done by an automated process. This was done by a steward. So we can store quite a lot of information about our confidence in that relationship. On top, we build the types, and so the colors of these represent the different areas I showed of the MIGA model. And I don't know sure you can read that, but this says what type of thing it is. So data set is an entity. Data content for data set is a relationship. And I don't think I've got a classification in here, but you can see, so the data model, if you look on our wiki, actually uses the stereotypes, the UML stereotypes, to show what type of thing this would be represented in the main model. And so, as I say, the colors map to this picture, and then this is the next level of detail. And here you see ODEF, that's the standard that we're using to tag and link things to different open standards. This picture and the detail is on the Atlas wiki, I think. Yes, this is where you can find everything, and you can drill down in and see each of the areas and the definitions that are available. And if you start the Open Metadata function up inside the Atlas server, you'll see all the types as well. So that's the type system. I also talked about access services. So when you start looking at the broader ecosystem and what needs to be involved, you realize there are lots of different types of platforms that are involved. And they each have slightly different interests. So an ETL platform is moving data. An analytics platform is picking up data, but building models as well. The governance platform is defining the requirements for management of data. Reporting platform is creating views on top of data. The data platform is creating and storing data. So they're all doing stuff with data, but they have a slightly different perspective. And this is just a more detailed list of the different types of tools we think need to be involved in this ecosystem. And so here are the access services that we have defined, and the ones in orange are actually being implemented as we speak. So there's things like the asset consumer. This provides interfaces to a tool that is basically accessing data and consuming it. The data platform interface is used to to allow a data platform to provide lineage information and information about new data sets. Governance engine is used to control technology like Ranger in order to basically set up rules. And then along the top there you see much more people-oriented services. So the asset owner, so how does somebody classify the data, look at feedback, give people permission. That's the asset owner. The subject area is for people who are expert in a particular subject area to set up the glossary terms and the rules relating to a particular subject area. Information view is used by virtualization engines in order to define views over data. Catalog is the search interface to allow people to find the data they're looking for. Community profile is the sort of core, allowing people to create a profile about themselves as they're providing feedback. So there's plenty to do, and the areas that are very interesting are, what do we need to capture around data science? How does DevOps, so if you think about new laws like GDPR, it's very important that all services, GDPR is about making sure you have permission to do certain types of processing on data. So that means that understanding services in an organization as they're rolled out is critical, so that you can do validation to make sure that the service isn't using data inappropriately. So being able to capture metadata during a DevOps pipeline means that you can do a lot of maintenance on metadata as the actual landscape is changing, but also put in governance points to make sure that where services about personal data are coming in, we're able to intercept and take necessary action. So there's a lot of areas where the expansion of our metadata model is allowing new use cases to be supported. Are we doing on time? Oh, that's good. Now, each OMAS service it includes an API, but it also includes a message exchange model. So we can integrate tools asynchronously or synchronously, and both use similar payload models. So a tool might use a combination of queries and asynchronous interaction. This is how they find out about what's going on in the repositories. So RS is the repository service, AS is the access services. We've got some lots of acronyms, I'm afraid, in the tools. And this is a very important component here. So the services themselves make calls to a special connector, which is the federating connector. So every external API, every sort of call from a tool automatically goes through the federator that will look for metadata locally, and if it can't find it, we'll try another server. That component is also responsible for routing update requests to the right server, so that updates only happen on the server where the metadata was created. Inside the main server, so that previous picture shows what's going on inside OMAS. Then you've got the repository services. So this is where all the logic of the protocol and the exchange is happening. Now, our service has to run in many different places. So this OMRS never makes any calls to the infrastructure. It always accesses the infrastructure through connectors. From the audit log, I'll talk a little bit about what archives are, but they're effectively stores of metadata that have been exported or created. The cohort registry is used by a server to describe all the partners it's working with. The topic connector is used for exchanging asynchronous messages with other repositories. This is the interface that a repository implements in order to be part of the ecosystem. So basically, we build a wrapper around the APIs of an existing repository. And this component here takes messages from a repository that's in a proprietary format and turns them into open metadata messages that can be understood up here and then distributed on. So the connector framework is a small component in this architecture, but it's absolutely critical to allow us to support the OMRS in many different deployment environments and even have choices. So, for example, the audit log actually is an array of connectors. So you might have audit messages going to a local store, but actually also being posted out to a centralized administration to pick up issues that are going on inside the metadata repositories. So the aim is a very flexible, many options in terms of deployment. Now, inside the repository services, this is actually a very big module, is the pink area. This is how we support the OMASs. So this is where the federator is. This is where we federate events from different different metadata repositories and bring it up to the Open Metadata service. The cohort services manage the asynchronous exchange of metadata and the registration of the server into the Open Metadata highway. And the local repository services provide calls to the connector and the event mapper to connect to what is the local repository. Because this is a peer-to-peer environment, every single communicating repository effectively has this running either as a proxy next to it or within its own content, its own function. And this is going to be an eye chart, but I'm just showing you to say this is what's going on inside the server. So the colors are the same as the previous picture. And the bit that's interesting is that depending on how we deploy it, some of those components, let's just go back, some of these components are either enabled or not. So if the server doesn't provide the open metadata access services, the enterprise services are not enabled. If there's no local repository and all metadata is being accessed from remote repositories, this is disabled. And if you just want to provide a local solution, we don't deploy the cohort services. So these are all turned on and off by configuration. And then when we start the server up, each of these pieces are started up or not, depending on how it's configured. But basically, we do a lot of passing of messages from. So this is communication with the other members of the other metadata repositories, and so we might get events coming in, and they're passed through here to the local repository, or up to the enterprise access, the Open Metadata Access Services. So it's a very, again, deliberately decoupled architecture internally to allow us to turn off and turn on different types of function. And here is the pluggable point where details of the actual real repository, so when the vendor product sits, are implemented there. So now I mentioned that there were archives. So we have, like I said before, we've defined about 350 types, and they are stored in an open metadata archive to allow them to be loaded into different repositories. So these are loaded automatically into Atlas, but other vendors may want to have their own implementation, and so they can load these types. They are stored in a JSON format. And through that technology, we also provide support for content packs. So somebody could build a GDPR regulation pack that has all the metadata that defines a governance program for supporting GDPR, for example. And then that can be loaded into any open metadata compliant library. And we're working with the ODPI to actually run teams of subject matter experts to build content packs so that people who are adopting the open metadata technology can have accelerators effectively for their governance program based on the experiences of others using this technology. The other thing we can do is export metadata into one of these archives, either for a backup or as a means of transferring metadata between repositories that are never going to be connected over the network. So we try and make everything work twice for its money. Adoption is key. So the technology is written assuming different integration patterns. So there's the caller integration pattern. That's where a product decides it's not going to have its own repository. It's just going to support the open metadata access services and rely on somebody installing an Apache Atlas or another type of repository that supports the open APIs. And so that's the pink one at the far end. That's the caller style. Native is where you take these open metadata libraries and you embed them in your server. And when you run Atlas, that's actually what you get. The adapter pattern is the one we expect a lot of vendors who have a mature metadata repository already, and it effectively wraps the APIs and the event management of the existing product using the connector architecture, and we then use our own the open metadata technology through those connectors to actually provide the exchange of metadata. And then there are a number of frameworks that allow different vendors to plug in analytics and other types of value-add function into this ecosystem through the plug-in patterns. That's more where you're building Java components that plug into the environment. So this is just a little bit more detail on each. As I say, with the caller, the metadata repository storage is provided by some other component, and all the product's doing is the UI and the interaction pieces for that, for that value-add function. The native pattern is where we embed the open metadata function directly into the server, so the APIs are native on that server, along with whatever proprietary function is provided by that server itself. This is the adapter pattern where this is an existing product. It has APIs, and so you build a connector that will call these APIs in response to a standard open metadata connector API. And then when repository changes happen, it may produce proprietary events. And the event mapper's job is to take those events and turn them into things that can flow out on the metadata highway. So these, and it may use, it might be that this says this record's changed, and it then calls the connector to get more details about the record in order to fill out the repository. So this means that for two Java components that are doing this mapping between the two, a vendor can connect into the ecosystem. They run this simple server, the repository proxy server, and their product is now part of the ecosystem. And the plugin pattern, which was for the components, can be connectors to different types of data platforms. The discovery framework, which is analytics to actually capture the characteristics of data, and the governance action framework, which will cover things like stewardship and different types of governance actions around things that are discovered in the ecosystem. So you might have an environment where you've got different products all connecting in using the different mechanisms, but as far as the exchange is concerned, none of them are affected by the integration pattern choice made by the particular product. And then the organization that's running this chooses how the different repositories are connected together. So here we've got different integrations. So this one's using the adapter pattern, so that's the repository proxy. This is the proprietary tool, and then the other two are natives running, and everything, all the metadata is being shared between the three repositories. In a bigger organization, you might have, this is Europe, and this is America, but you also might have an organization that wants to see both. So any request coming in here will see all metadata from both cohorts. If we issue a request here, we'll only see metadata from cohort A. And that's controlled by configuration. So when the repository starts up, it says what cohorts are you connecting to, and you can provide 1, 2, or none, up to as many as you like. When a server connects, we have the shared infrastructure is a topic. By default, that's a Kafka topic, and the server just needs to know where that topic is. And they post a registration request. And if it's the first server, as it is here, that registration request is pretty much ignored because no one's listening. But when the second server comes in, there's an exchange of messages, and the two are now able to talk. And by that, they can each make requests to each other. So here we see that the requests from server 2 are now picking up pink metadata as well as blue metadata, and vice versa for the other server. And then the replication function goes through the topic layer. So if, for example, this server is not always available, we have cached copies, read-only copies in server 1, so that the server 1 users are not affected by the availability of 2. And that's quite important for things like governance definitions, which don't change very often. So if this is, say, the governance store, and this is an operational store, you've got it locally to make sure that that metadata is always available. And this is all configured by rules in the technology. I mentioned a bit about the ODPI. The ODPI is where we are meeting to literally build out content packs and help and build tools and things to help vendors become compliant. Because the strength of this technology is not just in the technology foundation that we've built in Apache Atlas, it is also in terms of how much adoption we can get both in user organizations and in between vendors. So the ODPI is a great solution that we have, that, as I say, that brings value both to vendors and to our governance professionals. So, bit of a rush, but we're at an incredible time when it comes to data, and there's so much we can do. There's so much data available, and the tools for data science and the use of data and managing data are phenomenal. And we're being held back by the fact that we don't really understand our data and where it's come from and how it can be used. So what we're doing here is trying to embed metadata into the data platforms as a standard. In the same way, I mean, years ago, you used to buy security as an extra product to put on your laptop because it was secure, the laptop wasn't secure. Now it's embedded. We're thinking about taking metadata management and embedding it in as many places as possible so it's managed as automatically as possible. So open source contributions through Atlas, and then the sort of more content and compliance piece will be done through ODPI. And so please join us and please help. So any questions? There's a lot of detail. You're all stunned. Okay, well, yes, please. Mm-hmm. Mm-hmm. That's also included. Yes, we're looking at data at rest, data in motion, APIs, and what was the other one we're looking at? So we are looking eventing. Yeah, basically everywhere where we need to understand the data structure is critical for this. And that's the interesting thing we can do with open source. We're not at all limited by the existing marketing boundaries that tools find themselves. You know, this is an API tool, this is a data tool, etc. We are just basically saying, no, we need to cover everywhere where data exists. Yes?
So I've been using Atlas version 0.8 and now one alpha. And when I actually see what the application is and compare it to your second slide, I see the vision, but I still see it's far off, right?
Mm-hmm.
So there's still a long way to get to your first slide, or the slide where you have boxes and the colors.
Mm-hmm.
And is that the real, or it's something that maybe
There is a lot of code going into the thing. So we're hoping that in version 1, which is a few weeks off, we will have the OMAS, which is the repository services, and start to see the OMASs coming through. Over the next few months, that will fill out fairly fast. We've done an awful lot of design work early last year, and we really started coding come September, October through to now. So we're having the team is growing quite rapidly as well. So I think over the next 6 months you will see a huge improvement in the maturity of what we have in the product. Mm-hmm. I think that's it. Any more? There's one.
great initiative and obviously very much needed, you know, it's a full room. But up to the point where you talked about the content packs, I was left with the impression that what you're building is basically a meta model. You don't actually have domain models. So it turns out you actually do. But where do these come from? I mean, since you're using this technology, you obviously are aware of, you know, of the fact that there's a dozen domain models out there. The most prominent that people are aware of is schema.org. Do you actually reuse any of that at all?
So we've built the basic model around the standards, but it's an extensible model. So an area where we need a fair amount of extension is, say, in the industry-specific aspects, and that's really where the content packs would come in. The core of the metadata comes from our experience with different metadata products, and you find that they're all storing very similar things, all with a slightly different function. So that's where that core model comes from, but it's really not getting into too many, not into too many domains, specific domains around, say, particular industries, or sort of like customer domain type things. So. Okay, I think that's it. Thank you very much, everybody.